Right, here's the second electromagnetic device that uses the motor effect, and it is the loudspeaker. Something we use every day, even if it's in headphones. It's the same principle. Okay. Now it literally uses the motor effect, but it uses it in a slightly different way than obviously electric motors. Now to quickly demonstrate a speaker in action, I've got a signal generator, my loudspeaker from home. Anyway, what does a signal generator do? It generates a signal, yeah, but what kind of signal? Well, it actually generates a voltage. It generates an alternating voltage. That's all it does. These are designed for the classroom. You can change the frequency of the voltage. You can change the amplitude of the voltage. Yeah, you can also change the shape of the waveform, but I'm going to keep it on a simple sine wave. Okay, now the alternating voltage causes the speaker to work. So this drives the speaker. All right. Now we all know that sound is created by vibrating objects. The vibrating object in the case of a loudspeaker is the speaker cone. So you might notice when you listen to your loudspeakers, if you take the front cover off like this, you can actually see the cones there. And there's usually two cones. Some speakers, larger speakers, have three. This is for the lower frequencies. This is for the higher frequencies. That's usually called a woofer. That's usually called a tweeter. Don't ask me why they're called them. Anyway, quite a high frequency. We're looking at about 80 hertz there. We take the frequency up, the cone will vibrate at a higher frequency. Okay, we take the frequency down, the cone will vibrate at a lower frequency. And similarly with the amplitude. Now, as you know, with sound, and especially loudspeakers, frequency and pitch, and then amplitude and loudness, they are completely separate things. The frequency, or the pitch of the sound, is the frequency of the vibration. So that's how many times a second the cone vibrates. The loudness is the amplitude. Now, amplitude is how far out it vibrates. Now, they're two very different quantities. So a loud sound, the cone will be coming quite far out. A quiet sound, it will be moving a lot less. The frequency or the pitch is just literally how many times a second. Okay. If I take the frequency right down, we might start to be able to see the cone vibrating. Now that's the lowest threshold of human hearing is about 20 hertz. Now you might be able to just about make out the actual vibrations there. If I take it down even lower, we can definitely see the vibrations there, can't we? Now that's better because we can see what I mean by loudness and amplitude. That's on maximum amplitude. That's on a lower amplitude. That's why it's quieter. That's the difference between loud and quiet. Still the same frequency, the same number of times a second, but the cone's coming out less. Now that's how our loudspeakers work. Instead of having a signal generator, we have an amplifier that basically feeds quite a complex waveform, i.e. music or speech or any type of audio is a lot more complex than a simple sound wave. It will be a very, very complex waveform of varying frequencies and loudness, and that's what the music is. And that makes the cone move in exact unison with the signal we're putting in. Okay? Now, we're not here to talk about sound, are we? We're here to talk about electromagnetism. Now, how does this thing work? Well, what I'm going to got here, okay, is another loudspeaker that I've dissected for you. And it shows much more nicely how loudspeakers work. So basically, like I said, it's something to do with the motor effect. So if it's a motor effect, we need a coil and a magnet. Now, regular loudspeaker, don't try this at home with yours, but I've cut around the cone and then pulled the cone out, and you can see that the cone is actually only attached at the edges. Now what I hope you can see there is two things. Well, here is the magnet. This is why speakers are really heavy, because they have a huge, a very large permanent magnet. Now we can tell that's a permanent magnet because obviously the pen is stuck to it. Now, this is it's a different magnet to what we've seen. You see the circle in the middle? Okay, now that's the North Pole, and the ring on the outside is the South Pole. So the field lines radiate out from the central North Pole, okay, like spokes on a bicycle wheel. So that's the magnet. We'll come back to that later. Can you see here the coil? A very, very thin coil of wire that's attached. Each end of the coil here is attached to the outputs on the speaker, which I'll show you in a minute. Now the coil fits snugly into the gap between the North and the South Pole. Okay, so if I just place it back in, okay. Now let's see this in action. There's the terminals. So if we go one side with a crocodile clip, the other side with a crocodile clip, and then, so our cone is just sat back, all right? The coil is in that gap that I showed you. Okay. And if we have a look at this in operation now, see, jumps out. Okay. Now the reason it's jumped out is because the cone is not attached anymore. Now if the cone was attached, it would just vibrate up and down. In fact, I can make it vibrate up and down if I put the coil back in place. Okay. There it is. Right, so now the loudspeaker is in place. I've put that coil back into the gap. As you can see, the loudspeaker is acting normally, but because the coil's not attached, it just jumps out. Okay. Now I can increase the frequency. Okay, I can take the amplitude down. There you go, there's the amplitude on maximum. But that coil, because we've got an alternating voltage producing an alternating current in the coil, okay, that force, that F equals Bill force on the coil keeps changing direction. Okay, because it keeps changing direction, because the current in the coil keeps changing direction, the force keeps changing direction, so it makes the coil flip up and down at exactly the same frequency as the electrical signal going in. Okay, and there we have it. There it is. So the coil, there's an alternating current in that coil as we speak, but it's not doing anything because it's not in a magnetic field. When that current carrying coil, that alternating current carrying coil, goes into the magnetic field between the circle and the outer ring, that's when it vibrates. Okay, quite simple really. Right, there you have it. That is how loudspeakers work. Thank you very much.